Hello class. So far we've been able to deal on the topic of fluid mechanics, and we've looked a lot of things that has to do with fluid mechanics. We've looked at first we started looking at different solids, different states of matter, which we looked at solid, we looked at liquid and gases, and we had to explain the differences between those various states of matter. And we therefore said that when we are talking about fluids, there are two things we want to study. We want to study liquids, and we want to also study gases. So far we've gone through everything. We've looked at pressure, we've looked at density, we've looked at volume, we've looked at buoyancy and Archimedes principle, and we ended up with fluid flow. And in fluid flow we had to look at Bernoulli's principle, and from there we could be able to see some applications that we have in our normal day life when we are talking about fluid flow. And some of the examples we looked at was airplanes and the Bernoulli principle, airplanes and the Bernoulli boat. So today I just want to kind of run down with the clicker questions that we have today. So I'll try to answer them and try to provide an explanation to those questions so that you can better understand how questions will be said or how it goes. So follow up as we go along. Okay, question one is, at which hole is the cup in the cup is there more pressure on the water shooting than out of the hole? The question is looking at this. So if you compare this, where will water flow? And if you see this drawing, you're gonna see that it will be generally hole 3. That'll be because what? Because we said that pressure increases with depth. You see that hole 3 has the higher the depth. Look at this height. Compare this height to this height to this other height. You see that this height 3 or hole 3 is higher than hole 2, which is higher than hole 1. So that's the reason why our answer will be hole 3. Does a 3-meter deep shallow lake or a 6-meter deep small pond exert more pressure? Here they're asking us the question of more pressure. And look at, we're talking about 6 meters deep and 3 meters deep. Now if you compare the height h here, the height here will be 6, the height here will be just 3. So we said pressure increases with depth. Therefore, just looking at this question, we're going to say that the one that has a height of 6 should be obviously the one that's going to exert more pressure. And it's possible for us to consider B. But let's look what the question is. Yeah, the question is 6. Deep water, great pressure, like we've been explaining, pressure increases with depth. Now there are 3 containers, each with the same bottom surface area A and height h. Which one contains the most mass of water? Now if you want to talk about the most mass of water, firstly you have to talk about the volume. You see that the volume here is small. It looks like this is a little bit smaller, but this looks bigger, right? Now because the volume here is bigger than all the volume in our region 2, then it's possible for us to decide to say that the mass of the region 2 will obviously have a bigger mass than any of them. Why? Because remember we said density from the definition is mass of volume. Remember? And from here it's possible for us to find a relationship between the mass and the volume, from which we have that the mass will be equals to the volume divided by the density. Now notice that there is a direct relationship between the mass and volume. If the volume increases, the mass will increase, and if the mass increases, the volume will increase. And therefore we can see that since the volume of region 2 is higher, then it will contain more mass than any of the other masses. So the answer will be B, which will be 2. Now here are 3 containers, each with the same bottom surface area A and height of water h. The container exerting the greatest pressure on the bottom surface is, now we have to look at the area, right? We've talked about pressure, and we said pressure is force over area. right? And which means that if the area decreases, the pressure is going to increase, right? But if the area increases, the pressure is going to decrease. Now that's what we said from the beginning of the class, because you can see an inverse relationship between those two. So what do we do right now? So from here we look at which one has the smallest area. You see that all of them, they have the same area, and because they have the same area, they will also have the same pressure. So the same pressure acts on all of them, and our answer there is D. We're going to continue with the next video, which will be question 6 and the rest. Thank you.